Welcome, everyone, to AI Agents Hour. I'm Abhi. I'm from Mastra. And yeah, thanks for joining us today. It's going to be a pretty chill stream. First, we're going to play Where in the World is Abhi Today? And I am in a small town in Belgium called Mechelen. I don't know if you've ever been there. Plus one in the chat if you have. This will be a chill stream. I don't even know if the Wi Fi is that good. But thanks for being here, everyone. We have a nice show as always. We are doing some AI news. Then we're going to talk about agent networks. I'm going to bring Tony on. And then we're going to just do a pairing sesh with the team. Should be pretty chill. Yeah, let's get into it. Oh, also some quick news, I guess, or pre-news. We have this AI agents book that we wrote, the principles of building AI agents, and a V2 is shipping for that, which is great. And I would like to give out some versions of V1 to people watching. Now, there are some rules here, and I'm going to have to state them, um, you know, over and over again, like we do in live streams. But let me tell you the rules, and then you yourself could win a book, and I'll ship it to you. And I guess I have to repeat that multiple times during the stream, but we'll ship it to you. I'm only gonna do like 3 today. So this is how you get it, and I'm gonna have to say it multiple times again. But if you can tweet about the book and tag me, and then if we select you, I'll send you a D. We'll send you a DM. Get your address. Here's the problem, though. We can only ship to a couple countries. So, like U.S., of course, Canada, Sweden, UK, Germany, Japan, Belgium, where I'm at, France, Australia, Spain, Italy, Netherlands, Poland, or Switzerland. Otherwise, you just gotta settle for a digital copy. So, yeah, just send up. Just post a tweet about the book and how much you want it or something, and we'll send you a copy if you live in one of those countries and shit. All right. It's weird not having a co-host for this. Thankfully, I have some friends on the way. But yeah, let's get started into the news. First thing I wanted to talk about today is kind of AI related, kind of not. It's a tweet from Guillermo. So let's go through this. One of the painful lessons in infrastructure engineering is everything misbehaves. Your own client code is your adversary. You need to bake in load shedding, circuit breaking, rate limiting, observability, checksumming on every endpoint and layer of the stack. Now, this is in response to T3 chat, which had an outage. And honestly, like when these things happen, you got to hug people who are going through this. People in the chat, have you ever been through firefights, especially when it's a third-party dependency? It just sucks, and there's very few times you feel truly helpless in your job, right? And this is one of those times where you try to do something that you really can't control, but it's no one's fault, it's just the way these things go. So T3 chat, if you guys don't know, is a very popular, I guess a chat, AI chat. It's really fast. It's from Theo. You can switch models. It's like really cool. And they've been trying to work towards this like next version. And I resonate a lot with this tweet because I've been here, and I think a lot of us have. And I really appreciate him posting this accountability. It just keeps it transparent. These are the things, these type of posts here are what people talk about internally, like if we have for example, we've had outages on Mastra Cloud already actually, I'll tell a story about that. How's that? But I can't see the stream, so let me just move. Nope. Okay, great. I can do this, and then I can see you guys here. Okay, great. Okay. So I'll tell you a story about this. When we first started Mastra back in October, we got into YC at like January let's say January 6th or something. We had our cloud product done in like, 3 weeks or so, and it wasn't good, but it was like an initial version. At the time, YC was giving out these like credits for Google. And so we got our Google credits. Actually, we haven't got those credits yet, by the way. So fucking Google, give us those credits. But we met with our account manager, and we were like, hey, like the default settings in Google is only 6 VMs, and we're going to need way more than that. So they were like, oh, no, you can just do a quota increase. Okay, you can do a quota increase whenever you want. I'm like, all right, sure. So our bad is we fucking procrastinated for a long time. And then one day, people started using us, right? And we blew through 6 VMs, and then no containers could get scheduled in our cluster. So we go to the quota and we add the quota. Hey, we need 100 VMs, right? The quota gets rejected immediately. So now you're like, okay, what are you supposed to do? We escalate to the account manager. Account manager's like, oh, the quota team is a different team than the account team. So I need to do a separate quota. Then they also asked me if I had a support contract, which I'm like, dude, I'm on the startup plan or Google for startups or something. So then we are down for about 17 hours, That's like not good at all. Thankfully, it was like very few users and stuff, but like it's like truly a place where you feel very powerless. So you always have to hug your ops people because sometimes you go through this, right? So let's go through this post. He's very transparent. I really commend him. And he's very funny and vocal on a lot of stuff in the AI space. So if you don't follow him, I'm sure you already do, right? But maybe you should if you don't. So they had an outage. It's working now, but let's see. Let's go through. So we've been working hard to move over to Convex as our data layer and sync engine for T3 chat. Convex is a great product. This might seem like a database swap, but it goes much deeper. It's effectively a full rewrite of T3 chat. When you do full rewrites like this, you have to kind of like gauge like which path you're going to go down. Are you going to do like a full cutover? Are you going to do like a progressive change where you have to do dual writing and things like that? Most of the time you want to do something that's easiest, right? But the problem is to do like crazy rewrites, you have to usually do the one that's the most annoying. So I'm not sure which option he picked, but he's doing it. So we had 3 failed migrations. We finally had a successful move around 8 p.m. last night. This is our lowest traffic window, 40% of our peak traffic. That's really cool that he knows that. All looked good. I was pumped. A month of effort finally shipped. I literally slept for 12 hours, woke up to utter chaos. Dude, I know how this feels, man. You go to sleep thinking that everything is chill. Then you wake up, everything is fucked, okay? And then you find out, let's say you wake up at like 8 a.m., right? You find out that it started at 2 a.m. So then obviously maybe someone's looking at it, maybe someone's not, but most of the time, some of these things just happen. And then if you don't have good paging and stuff, you'll never know. So TLDR, traffic spike took down their WebSocket connection layer, some bad client code, and from the React package caused a reconnect loop that effectively DDoSed the Convex endpoint. I wonder if it's some use effect thing, to be honest. Convex will have a detailed write-up in the future. We should take a look at that when that comes out. Yeah, so hey, I just said that. Actual status updates and reporting in app. Right now, outages reported via Twitter. We have a real app now. We shouldn't be doing that. 100%, dude. That's a great takeaway. Paging system. Like I was just saying, if you don't have paging, then you just wake up and it's like 6 hours of darkness that, man, people probably hating you for that type of stuff. I hate PagerDuty too, Theo, but I think it's the best one given how the competitors have just fallen away. I think Fire Hydrant, Incident.io. I don't know. There's a bunch of different ones, but I guess PagerDuty has lasted the test of time. Maybe, I don't know. Chat, what are your thoughts on PagerDuty, if you have any? Okay, a lot of the issues we had today caused by bad client-side package DDoSing Convex. Even when we pushed to fix, a lot of users were on the old version still and would stay on that version until refreshing. Yeah, that's the classic browser client issue, man. That sucks. Please refresh buttons. No one reads anything, so it's never enough. And so you can't really have client side issues. You have to be a lot more. It's got to be a lot more like careful about that. So, oh man, I feel bad for the evaluate all upstream providers to make sure they are prepared for T3's chat load. Very good. Yeah, like this. Um, when you're using other third-party projects or products, you just got to make sure that they're ready for prime time when you are. But yeah, so this is the I guess the post-mortem here, or like the accountability post. But blameless stuff. I think he got a lot of heat as always, but that's just because he's like the notoriety, like it's got a lot of views and stuff. But hug your ops guy, hug your founder who's going through some outages. Like, this is a community of people. They're all doing the same shit. We shouldn't be hating on people for operating our products. Like, operating a product it's a job, right? You don't just get to build software and just leave it around rotting, right? So yeah, that's our first one. Thank you for that. That was cool. 64 of you here in the chat. I know it's boring with me here probably, but it's going to get more exciting. I have just two more news things and we'll get on to some coding. Next one is Osmosis. So Osmosis is actually written, like the company Osmosis is from our YC batchmates. And also Andy from Osmosis was on our live stream teaching everyone how to do ML, which was cool. So let's talk about what Osmosis Structure 0.6b is. So this is like a smaller model, and it acts as a model that can just take any unstructured text and then turn it into a proper structured output. So why is this important, right? So first, SLM is a really cool word that no one really uses right now, right? It's a small language model because we're all using LLMs, right? Large language models. But small language models are good for specific tasks or when you are very specialized in what you're trying to do. And so in this case, this SLM is designed to help create JSON or structured output. And it's super small, but based on its benchmarks, they can turn any unstructured text into a JSON schema. Why is this important? I was saying that structured output support really depends on the LLM. And so I know a lot of our tooling uses you can do generate object or generate with a JSON schema or a Zod schema if you're using AI SDK, or if you're using Mastra, we have the output parameter. But then it really depends on the model that supports that, right? And it also comes down, and obviously between LLMs, tool calling is a different thing. We just released a blog post on tool call compatibility, which really shows you how you have to coerce the LLM to do this type of work. And then taking unstructured data like this and giving it no kind of if you just did a unstructured output and then you kind of just gave it a JSON schema, it'll do its best, right? But it'll miss things and stuff. So I would try using this. It's pretty cool. We're gonna release something. We're not gonna release an SLM or anything, but we have some application level utilities and benchmarks we can show that you can also achieve this with an LLM, sort of. But the beauty of SLMs is it's a really cheap cost, right? Because they're open source, right? You have to kind of run them. We could go through those model providers to do it, and you pay significantly less money to do so. So that was cool. One thing is from the tool calling compatibility research that we did, Anthropic, Claude is the best at tool calling, but then the new R3, DeepSeek R3 is amazing at tool calling. And actually, why don't we talk about tool calling real quick? So, all right, let's talk about what we did just to toot our own horn. Let's share this now. So yeah, this is a blog post by Daniel Liu from Mastra, and we had this problem for the existence of the company so far is just everyone was having like tool call errors across different models, and so every time we'd get issues in our Discord or in GitHub, they would be like, "Hey, I'm trying to use this tool, but it doesn't work with X model." Then with MCP coming on the scene, that becomes even harder because usually when you're testing your MCP server, maybe people are just using one model. Maybe they're using OpenAI, which is generally good at tool calling. So, like if you're only testing your MCP server with one model, then your tools are kind of biased towards working with that model. And that's kind of what we discovered. Like a lot of people were bringing their own MCP servers from anywhere, and you can never know the quality of an MCP server, and you don't really know the quality of it in relation to the model that it was being tested with or the model that you're using yourself, right? So we had to do something about it because the amount of issues of tool call errors are one, it's kind of distracting to like true issues because it's not really something that we controlled, but it's something that we could do something about. And if you can do something about it within a framework, it's like the right place to do so. And thirdly, we're going to extract this tool calling magic into a separate package. So if you're using other frameworks or libraries, maybe you could take advantage of it too. It'll be called at Mastra Schema. I don't know if it's a great name, I guess. So what do we do? So first, let's talk about the results. Like before, man, shit was kind of shitty. Like shit was kind of shitty. The tool compatibility rate was just erroring, and 16% and 11% of your tool calls erroring is a lot. You can imagine it's a lot. And we did a whole test where we created a bunch of tools. We tested them through different like benchmarks or different models to see like do we get a tool call error or not, and like why we got the tool call error. So we scoped the problem. Here's some really cool things we noticed, right? In OpenAI, if you did support a property, we would throw an error, which was like invalid schema for tool X. This is an error that many people see. Gemini models, they don't explicitly fail, but they ignore things like the lengths of a string or if you have some minimum array requirements. And Anthropic is chill. DeepSeek and Llama weren't the best at tool usage and maybe sometimes don't even call the tool. And even with prompt coaxing, it didn't really help either. So that was just not good, and like many people are using DeepSeek and like Llama models through like Fireworks AI, so that's cool. The things that seemed within our control were to fix these schema errors and ignore schema constraints when given so. So like if you want to truly improve tool calling, you got to go to the model itself. So we did different approaches, right? So first we did the input schema. We tried to transform the output, make sure it all shaped properly. It didn't really work. Then we tried to inject like more into the prompt, but then like it works for some, but not for all, right? And you have to do something that's a little bit more general here. So finally, is like we just did a bunch of little things like we try to do schema constraints into tool instructions. We went a little bit deeper. We added better tool descriptions. We modified schemas based on the model. So, for a given model like O3, we kind of changed the formatting of this stuff so it would better know what the thing is. So the user doesn't have to be like on the hook for knowing how to do everything, which is the beauty of a framework. So you can see before we're just doing string URI, and then now like maybe URI is not really like universally accepted. So then we would just say, hey, this is a string, but in the description, like this is how it looks. And this works surprisingly well. So anyway, that's cool and kind of in line with just improving the LLM response. So that's dope. Oh, Rude Boy's here. I'm gonna show this. Is it 16 of 100 calls to the same tool that are failing, or is it some tools work and some tools don't, or others don't? It's definitely a mixed bag, right? And it's based on like the schema, and it also based on like what you're trying to do in that call too. We'll post the. I think you did post. I'll link the data here that everyone can take a look at. Um, we have this Google sheet if you're interested. Um, and you can just look at all the data that we collected here. I don't know if you can actually get it, but it has all the data. I'll share it. Like we can go through it right now. 1 second. And let me share this shit. So we have this. So we tested pretty much all these models, and then we tested like a tool with, a string property, all the different types of like constraints on it. If it was like, in Zod, you can do all these things, right? Numbers, etc. And then we wrote just tools that leverage these things, and we got to see like, where things fall. So we're gonna do more work here. Like this is just the first step, but we can like definitely see the number of tool call errors going down. So that's cool. And then let's move on to. I have two more news. I know like news is always boring. At least it is to me. If you're just joining here, 84 of you, welcome. I'm Abhi from Mastra. Today I'm solo dolo. Usually I have a partner. And if you're just joining us, I'm just going through some AI news. We talked about T3 chats outage and how we should all be more empathetic to people. Then we talked about Osmosis's SLM to make structured output, unstructured text to structured output better. And sometimes, and this is from Andy, using smaller models is sometimes a really good way to get more efficiency. And using Osmosis, you can actually like like if you're really into like RL and making smaller models, they're a great place to go if you've got the money. And you can essentially wrap your models and then eventually create a smaller model that is more trained on your use cases. SLMs are really cool, and I think that's going to be a big subject area that comes forward. Then we talked about tool call compatibility, which is like a natural segue. And us at Mastra, we did some research on tool calls compatibility. These will all be in the show notes after. I'll post those on Twitter. But yeah, that's where we're at. We got, I think, one more. This one's a funny one. That's why I saved it for the end. And then we're going to bring in the homies. All right, this is funny. So I just want to talk about this shit because it's funny. Meta plans to replace humans with AI to assess privacy and societal risks. Now, this is not the first time I've heard a company doing their trust and safety through or like promising to change their trust and safety protocols based on AI. So let's go through this shit. Let's see, where did I put it? Oh, it's right here. Okay, so first of all, let's talk about like what is like the like society like the. Okay, let's talk about like there are people at Meta, and there's a bunch of algorithms and stuff too that like handle this, but like all the dangerous shit that's happening on Facebook and Instagram and stuff goes through like a content enforcement policy. Also, there are people like actual people that review these things. There's a lot of porn, just straight up. There's just a bunch of porn and fucking bad shit. I mean, okay, I'll just leave it at that. There's just a bunch of bad shit that these content moderators have to go through, and then they'll choose to do bans and stuff. And I remember my old college friend, Trevor Pottinger. He got his first job at Meta back in the day, to essentially write programs that assess if images are inappropriate or not. So we used to make fun of him about how much porn he was watching at work. But it's kind of funny though. And you can think that this can be assessed with AI. I mean, that's what they were essentially building, which was models to do detection. But let's see where things are going now. So, um, for years, Meta launched new features for Instagram, WhatsApp. Teams of reviewers evaluated possible risks. Could it violate users' privacy? Could it harm to minors? Could it worsen the spread of misleading or toxic content? The ironic thing here is they've gotten in so much trouble for this shit anyway. So even with all the reviewers, they got screwed. But anyway, they still exist. Until recently, what are known inside Meta as privacy and integrity reviews, that's the stuff I was talking about, were conducted almost entirely by human evaluators. Yes, but they had software too that helps them. But anyway, let's take it for what it is. But now, according to internal company documents obtained by NPR, who whistleblowed on this shit, up to 90% of all risk assessments will soon be automated. In practice, this means that critical updates to Meta's algorithms, new safety features, blah, 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 will no longer subject to scrutiny by staffers tasked with debating how a platform change could have unforeseen repercussions or be misused. Interesting. Inside, the change is a win for product developers because they can just ship shit, and then in theory, the AI will protect them. But then, how many people will lose their jobs? I wonder. Insofar, the process functionally means more stuff launching faster with less rigorous scrutiny and opposition. It means you're creating higher risks. Negative externalities of product changes are less likely to be prevented before they start causing problems in the world. Man, they're so lax with how they talk about this shit, huh? Especially if you run you have so many users that you could just tank economies and shit. Anyway. In this statement, Meta said the product risk review changes are intended to streamline decision-making, adding that human expertise is still being used for novel and complex issues, and that only low-risk deductions are being made automated. Nice. They save face here because that's what you should do, especially right now. I don't think we're there yet to do some full autonomy. But internal documents reviewed by NPR show that Meta is considering automating reviews for sensitive areas, including AI safety, youth risk, what the fuck, and a category known as integrity that encompasses things like violent content and spread of falsehoods. Dude, I just called this. This is what my friend was working on back in the day. That's crazy. All right. Okay. Now I'm getting skeptical. Former Meta employee engineers are not privacy experts. A slide describing the new process. Blah, 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 blah. AI-driven decision will identify risk areas, blah, 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 blah. Dude, these guys are super pilled on AI, which is cool. But I don't know. I guess I'm just a little negative. Let's just see. I don't really care about a lot of this shit. EU could be insulated from these changes. Probably because there's a lot of digital services acts going on over here. All right, I'm just going to do this last one. Is moving faster to assess risk self-defeating? Another factor driving the changes to product reviews is a broader years-long push to tap AI to help the company move faster. Blah, 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 blah. We're beginning to see LLMs operating beyond that of human performance for select policy areas. I wonder if they just hired bad people, though. Or maybe LLMs are really good, though. So this free capacity for our reviewers allow them to prioritize expertise on content that's more likely to violate. This is also says this frees up our caps or our salary space because we won't need many motherfuckers left. Okay. I don't care about this. I don't care about this. Let's see. Let's just see. I think it's fairly irresponsible given the intention of why we exist. I just called that. We provide the human perspective of how things can go wrong. Now, famously, old Twitter, had this same type of policy board, right? And sorry, there's a bunch of shit in the chat. I'll get to you in a second. Twitter also famously had this same drama, right? During all the in the U.S. at least. I don't even want to talk about all the. It's a very touchy subject, so let's not even talk about it. But Twitter also went through this, and they found that the content moderators were not acting in the right way. Now, that's okay. I mean, that's not okay, but humans have their own judgments and stuff too. So imagine, AI with the right system prompt can and it can change, right? And AI's opinions can change more than a human's. I think a lot of us are set in our ways, of course. Um, but I just think that is such an interesting article, and it's just hilarious that we're back in the same kind of conversations again. We've been automating stuff for years, right? So, but now with AI, there's opportunity here. Then people who want to keep their jobs, obviously, are going to be against it. I get it. I feel for them. And then, from the executive point of view, they're like thinking about it from dollars, right? I don't think they really care about risk and safety, to be honest. More money, more problems. But let's go to what you guys were talking about in the chat while I was going through memory lane over there. Cool. Let's Hey, Trevon. Thanks for you're active, or you're a repeat viewer. So I'm glad you're back. 103 of you here right now. I'm not going to do the recap because I got shit to do, but I will do it later. Last week I was confused about the Claude 4 hype and why the official stuff didn't seem impressive. Okay. I was mistaken. Claude 4 has 14% score improvement over Claude 3. That may be true, but I don't know if it's I don't know if those results are felt. They're felt by some, but not by many. So maybe some percentage of people are not getting the benefits. Or, I mean, I used Claude 4 over the weekend. It was pretty sick. So, but I was also not a believer last week when I first used it. So iteration is key. I'll just finish with Shrevon's thing. He says, I misread labels on the graph comparing two models. Okay, for sure. Then Rude Boy, I was CIO of a medical research institute and blocked all inappropriate images. Then all the researchers reminded me they needed to see medical images, which were getting misclassified. Nice. That happens. It's like if you I remember my friend when he was doing the safety algorithms, that people would post food that would get misclassified, like a hot dog or something, but or a jellyfish. Anyway, I'll leave it at that. EU really leads with online safety, for sure, for sure. Okay, so 119 of you. We're gonna go on to our next topic. I'm gonna bring in my homie. Okay, let me just send this over to him. And let's change. Did you guys see the countdown on the stream today? We're getting better at this streaming stuff, And with that, hey Tony, how do I make this? How's it going, Tony?
I'm good. How are you?
Pretty good, pretty good. We have about 127 people in here, so welcome. Just to do a little recap for you, because I did promise a recap. We did some AI news. We talked about Guillermo made a post about infrastructure and how you got to be diligent in response to the T3 chat outage. We went through that. We talked about some stories that Google fucked us over with the quotas, and we talked about how people should be more empathetic to people who operate software. So yeah, and then after that, we talked about Osmosis and the structured output model that they made. Talked about our tool compatibility research that we did. And then lastly, we talked about how Meta is trying to replace their trust or privacy and trust and safety and content moderation with AI. And it's just made a bunch of jokes about how that is more self-serving than trying to make things better. And now we're here to talk about agent networks. So I'll pass off the mic to you. Like, let's kind of just get into it. Let's educate first.
Okay. Well, let's talk about what agent networks are. Then I guess to start. So, as far as Mastra primitive goes, you have agents, which are like these individual LLM-based components, right? And then you have workflows, which lets you create this deterministic flow of actions, which may or may not contain those agents. Often they do. In fact, often several of them. And then there are specific control flow checks that you can do. Say, okay, if this agent answered in this or this way, then you do something else. If it answered another way, then you do, again, something a little bit different. But the control is fully up to you. Like, you have to pre-program everything. You have to control the cases. It runs only as long as you say that it should run, etc. Now, agent networks are kind of the other side of that coin, where you have just a group of these different primitives, agents, workflows, tools, and what have you. And you want somehow an LLM to figure out which of these primitives you should be calling. I think there's two main use cases for this type of interaction. One is more like it's kind of a one-off thing where you have some sort of unstructured inputs, and then you need to figure out which primitive to call, whether it's a workflow or an agent or whatever it is. And then it transforms the prompt or the input from that unstructured initial input into the thing that you actually need to pass in to that primitive, calls it, and then you get a result back. And then the other use case is like kind of more of a complex task, kind of task solving, where you need to call multiple primitives in sequence, and the agent needs to figure out which primitives to call in what order and when the task is actually finished.
Nice. Let's let me share my screen, and we can draw this out for our homies here on the screen. Also, I just need to make sure I got my windows properly. But everyone see my Excalibur? All right. So Tony was saying that there's two different kind of paths here, right? So let's talk about the first one, Tony. So let's say we have the network. So let's actually make this a big ass box. Let's say we have a network that comprises of what? So it has agents on A1 and A1, A2, A3. We can also have workflows. So W1, W2. Sorry, my Excalibur skills are slow. And W3. But then both of these things can have, I guess, tools, right? So T1, T2.
Yeah, the agent network itself can also have tools. So that's like an additional dimension in there.
And then we can, then we can say like AN T1, right? But then what about memory? So
yep. So agent network in itself has memory in it. That memory is basically used for what I kind of call working memory, or scratchpad memory, whatever you want to call that. It's basically memory that is associated with a specific task only. So if you were to run one of these more complex tasks that would involve, let's say at the end of it, like 10 different primitive calls, let's say 2 workflows and 8 agent calls with some prompt enhancements and all kind of stuff in between. The agent network's memory is what is used to record all of those like reasons for why a specific tool was called, all of those different outputs from the different primitives, just so when the routing model needs to again decide what to do next, it has all of the context that it needs to do so. But then in addition, all of the agents themselves can have their own memory, right? So when you create an agent, you can pass memory to that agent. So there are several instances of memory at play here.
Let's make a little bubble thing. Oops, sorry. The fuck? There it is. Oh my god. Let me just put M. Okay. We got M here. We could have an M here. And maybe we don't have M there.
Yeah, it is optional. So
also, to illustrate, workflow 1 could comprise of these two agents as steps, right? This could be a tool. So this could be like a tool like this that calls an agent. Sorry, the agent calls a tool, which is a workflow. Or it could just call a tool itself.
Yep. Or a workflow could have a workflow as a step. So.
Exactly. So boom. So now we're getting this network structure, right? And then even these could all be linked as well. And then A to A exists, so you could do this. And you can see that we're in this kind of structure. Yeah, let's keep going down this graph. So you were talking about the scratchpad memory. So I guess we can go through the first use case and kind of illustrate how that use case interacts with this network.
Yeah. So in the first use case, the memory is definitely less important because you don't really need memory to figure out how to just run one primitive. The only context that you have really is the unstructured input, and you have all of the different descriptions and input schemas and what have you, whatever metadata we have about each of the primitives that are registered on the network. Yep. So for that first use case, the memory is kind of, in a way, a little bit irrelevant. It's more if you wanted to show that in the chat interface, it becomes more of a traditional vehicle in that you could have a chat where you send one message that then executes one primitive. You get some kind of result back. You can send another chat message and it then re-executes, and then maybe it runs the same or some other primitive. So the memory is kind of more like a traditional agent memory in that use case, I would say.
So in our first, let's do like an example task that a network could do, and then we can maybe walk through maybe there's some more components to add within the network here, right? So let's say what's a good task?
Well, one of my favorite tasks, and I don't know if it's a good one to illustrate here per se, is one that I tend to need the most myself, which is you have some kind of unstructured metrics or server logs or something. I think server log is a pretty good one. So you're just getting a whole bunch of logs from some backend or whatever, and then some of those are maybe errors, some of them are warnings, and then you kind of want to figure out how serious what's happening. How serious is it? What's actually happening there? And then you need to determine some course of action for that.
So this is like the data that we're passing to the network with the prompt, right?
Yes.
Figure this shit out. Not like that, but pretty much though. Okay.
Although in the case of the first example, we would pass maybe just one log, like one error. Like maybe we would just filter out errors and pass them onto the agent network, and then it would basically figure out how grave is this error that we see in the logs.
Yeah.
So then the next thing would be that, okay, maybe it's some kind of a database connection issue, which is pretty bad. So maybe what it does is it runs a workflow that takes in.
Who's the one deciding that? Because that's the component missing.
Okay, so then the component deciding that is what we call the routing model inside of the agent network. And that's kind of the main driver. It takes in the initial input, it figures out, or it has in its context all of these different tools available to it. It has the memory attached, and it figures out, okay, what is the thing that best suits whatever is happening here after it figures out what it is that you actually pass in. If it's, let's say, a workflow, it figures out what do you need to do to take whatever the user put in and to actually configure that as the input schema of that workflow. If it's an agent, it usually creates a more specific prompt for whatever that agent is specialized to do. And then it calls that primitive.
Yep. So it has this reasoning here to then say, based on whatever was asked of me, execute the right playbook or the right move, which could be calling an agent, or it could be executing a workflow, or any mixture, and as we saw before, some of these things are connected, right? So by doing something, it'll also trigger the other components as well.
Yeah, it's more like it chooses the right registered entry points. So like you are in control of which one of your master primitives you want to be registered into this specific agent network. So those are the different entry points for actions to start. Whatever that agent does or whatever that workflow does, it's its own thing. But these are those primitives that the agent network has the ability to call with whatever tasks you're giving it.
Yeah, for sure. Okay, should we talk about the second use case?
Sure. So the second use case, one more thing maybe about this first one is like if we just did one kind of a sample error, like it could be, let's say, a database error, which seems pretty bad. So maybe there's like one workflow that's specialized in sending the right Slack message, creating an incident on PagerDuty and whatever. It does all these things. Maybe use an LLM to create a description and also to estimate like the escalation level of the issue. So there's a lot that could happen in that workflow. Or maybe it's something else where like the error seems kind of random and you don't really know what it is. So maybe you just call an agent to like give you a better idea of what's actually happening. And then you can follow up with another action yourself afterwards. So it could be used in a very multi-purpose way.
Yeah, because once you get the first response out of this work, like this execution, you could then be like, oops, sorry. You could then be like, oh, but how about X? You know, or like,
Yeah.
and then that would then trigger maybe these.
Yeah.
And then you can just keep talking. It's essentially you keep talking to the network in an iterative way. But
and that's where the memory comes in this use case, is really through this ability to like use those primitives first to maybe gain more understanding, but then also trigger those actions that you know are available to you, like trigger maybe a workflow to escalate things if the issue is particularly bad. It's all up to how you actually prompt it. Like if you prompted it to say run the most appropriate action instead of to give you more information, then that's what it would do, right?
Yeah, 100%. So like in this behavior of the network, you can talk to the network in a
Yes.
I don't want to say chat way, but you can literally talk to it. Unstructured text is just chatting, right?
I mean, you can chat with it as long as you're calling agents. It does really feel like chatting, at least to an extent. Maybe a little bit less than directly chatting with just one agent, but it does have a very similar experience. Whenever it does call a workflow, it's really more because you prompted it in a way that you wanted some action to happen. So it still kind of does feel like that. It's more like you just told it to do something and then it did that. So
yeah. Okay, so let's talk about the next. I'll take our diagram here and I'll just copy it. And now we're in this. And let me get rid of these. Reset my nice little state transition I was doing live, the colors and shit. But hopefully people like it. Actually, one thing, the amount of viewers has just bazillioned up. So let me just say what up to everyone real quick. 237 of you legends in here. I think some other podcast does that. But anyway, welcome. If you're just joining us, I'm just kidding. If you're just joining us, we're talking about agent networks. It's actually a very timely topic in AI in general, because this is the dream, right? This is what people want when they think about the future of AI. It's just like some autonomous systems just running based on you just saying something like unstructured like this. But we're going to move on to the next kind of layer of this, and I'll let Tony kind of explain that while I draw.
Sure. So the second use case really is more like complex task execution, where you need multiple primitives executed in sequence or in parallel just to do individual pieces of it, and then probably you need some other tools to then tie everything together at the end of it. Now this is where what I call like scratchpad memory earlier becomes way more important, because now instead of looping back to the user for the user to prompt something more specific again, the routing model is the thing that keeps prompting all these different tools, whether they're workflows, agents, tools directly, maybe even other agent networks. Like any of these primitives that you've registered on, to this agent network, the routing model can and will call them if it deems that appropriate. And there is absolutely no human feedback that you inject into this until the task is actually completed.
Nice. Shall we go through an example for this?
Sure. I mean, one kind of, I guess, obvious, maybe even like a little cliche example would be some kind of like writing of an article or a blog post or something where you have different stages. You have like the research stage, especially if you're writing an article. Then you write a draft, right, based on that research. Then maybe there's some kind of like fact checking involved, and then.
So sorry, you research.
Yep. Draft. Let's write a draft.
Fact
And then
check.
there's some kind of fact checking, and then you revise the draft, and then hopefully at the end of it you have like a fully polished, ready to go version. There may be research into like different things happening simultaneously. Maybe there's different topics that you need to research. You need to put those together. But those are like the individual actions that typically would happen. Now, if you were to ask an agent network that had, let's say, 3 different agents registered to it, it would have a research agent, or maybe a workflow that combined multiple agents to do research effectively. There could be like a fact checker agent, and then there could be like a writer, I guess, or like an author agent that's good at just synthesizing text in a specific way with specific guidelines for how you wanted that article to look like and all that stuff. Then, if you were to ask it to write an article about any given topic, let's say about, I don't know, about trains, different models of trains or something, then it would probably first want to trigger some kind of research, right?
So it goes to the routing model, and the routing's like, hey, I need to write something about trains. So I got to go from the routing model to the research model, right? Or the research.
That's what it'll probably figure out, because it's like, okay, I have all these primitives registered to me. This specific agent is specialized in doing research on whatever. So that's probably the place to start. So it's going to tell you something about trains. Then maybe, depending on your initial prompt, that research is not enough. So when the routing agent gets that research, it's like, okay, that's a good start, but I want to know more about X, Y, and Z, like maybe about the history of trains, because that wasn't in the initial research, or whatever, right? So it could be doing multiple kinds of research, either simultaneously or in sequence, if it just decides that the research that it got the first time is not enough.
Oh yeah, it could do research in parallel potentially.
Yep.
Nice. And also one thing to note, the routing model is the one prompting the agent, not the human.
Yes. Right? So what happens is you have this initial task description, which typically ends up being pretty long when you're doing complex task execution like this. So you're quite specific about what you actually want to accomplish. Maybe you also have some idea of which, like what your kind of concluding output should look like. Maybe you have some kind of a template or whatever. Like the description ends up being quite complex, but the routing model doesn't send any of that information to any of these individual agent calls or workflow calls or anything. Yeah. It creates its own prompt based on all the decisions that it's taken before and based on like where it's actually at in the current execution. So when it prompts the research agent, it will probably, instead of whatever your long description of a task is, it will probably just ask the research agents, hey, like, can you give me some general information about trains? And then once it gets that, it maybe figures out other areas that it needs to research, and then it will do that research as well. Yeah. And again, with more specific prompts saying, hey, tell me about the history of American trains or whatever.
Exactly. So like this, and like we're still waiting here. Let's say we're the humans. Technically, you wouldn't wait for something like this, right? It'd be a more background type of job.
Yeah.
We put this, like, write me an article about trains. Routing model is going back and forth here, just activating the agent. And then at some point, right, it needs to know that it has to go to the next agent, right? Like this one, for example.
Most
Or
likely, it will go to the author thing. It depends on how you set up the instructions for the fact checker. But the way I was thinking about it is the fact checker is more specialized in just reading through like paragraph formatted like actual articles and then
Mhm.
trying to spot errors. So, but it could go either way depending on like how you instruct those agents to be called, because that's ultimately what determines what the routing model is selecting is based on how you describe your agent's use cases are. So it could be either way.
Yep. And so then at some point it needs to be done, right? It can't go forever. So how does it determine that?
Yeah. So it fully determines that based on what is the current execution phase where we are at. What is like the latest stage of everything, given the memory that we have of this task execution and what the actual task description looks like. So in this case, if we ask for an article, when you just have a whole bunch of research in memory, obviously the agent will be like, oh, but we don't actually have an article. So we need to go to the author agent, and the author agent then writes something. But then the routing model knows that, okay, we haven't run any fact checking. That wasn't part of our initial prompt or our task description. That needs to be fully correct, whatever. So it knows that it needs to call the fact checker at some point. So it probably runs through that at least once.
Yeah.
Maybe there's something that the fact checker agent noticed that needs to be changed, in which case it knows to go back to the author again. Maybe there wasn't, in which case it just decides that, okay, I guess we're fine. There was nothing that arose in fact checking. We do have a full article, so that's where it ends the execution. If there was, maybe it'll run through the author agent again, just to do another draft. Maybe it'll do another fact check and then see if anything else comes up. But eventually, if the fact checking comes up with nothing, it already has an author draft, and that's what will be what it will then determine to be like that final output of that task execution.
So what's the structure of the memory? Is there like a template we're using in our agent memory here, or sorry, the AN memory, or are we using working memory, or are we just storing the responses in the thread?
So the way that it works right now is that it's based solely on resource ID and thread IDs, in the sense that a thread ID is basically, or the thread is the individual task execution, the resource is on the agent network. So this is how you can also like go back and look at all the decisions that were made. That's how it's structured right now.
Nice. So it's just a bunch of messages that were being passed back and forth, essentially.
Yeah, and those messages are really a combination of two different kinds of messages. One being kind of whatever is the final output of any given primitive that it runs. That's one type of message. And then there's three types total. Another type is the actual like routing event, or like the routing output, where it basically says why it selected a specific primitive, which primitive is selected, and what type of primitive it is. So we could say something like type agent ID, whatever is the ID of that agent, and then it would say selection reason, which is kind of like an actual human description of why it chose to run that agent at this given point in time.
Selection reason.
And then there's a third kind of event, which is like a completeness evaluation event. So after every iteration after it's done running any given primitive that it chose to run in the previous iteration, it always checks what does it think about the completeness of the task, given all the stuff that it's done so far and where it is right now. And for this, it also gives you kind of this human readable description of, does it think that it's complete, and if so, why, and if not, then why not.
Yeah. Very cool.
So what's interesting about this is all of this information becomes introspectable as well, right? Since it is like executing steps of a workflow, all of this is recorded. So if you were to want to like check why any of those decisions were made, so that you can maybe fine tune your prompt or fine tune some of your agent descriptions or whatever, you're totally able to do that. And that information is tied into the traces of the agent network execution as well.
Yeah, this is exactly this is the dream, right? This is the dream that people want. But what are the downsides of the loop style? Because I could already foresee there might be some.
Well, one is definitely cost, right? Like with every primitive that is calling, not only are you having to pay for the tokens of that primitive, whether it's an agent or a workflow that is calling an agent or several, but you're also paying for the tokens of the routing agent itself. The longer the task, the longer the memory, so the longer the context window of the routing agent, which again contributes to the cost here. There's of course a lot that we could do, like summarizing certain parts of that memory, and we do want to probably work on adding some tooling for that so that it becomes more feasible, especially like for very large and long tasks.
Yeah.
But there's no way around that. It's going to be pretty expensive. So this is really reserved for more, I don't know, for the few and select tasks where it's definitely worth putting that money in. Like, let's say there's some kind of automation that just makes your team work more effectively. This is probably worth it, but it's not something that you would replace all of your agents with necessarily.
Yeah. And like, this is like more of like a like a statement here is like, even if we have this utopian solution working like 100% well, do you think we would recommend it all the time though?
No, I don't think so. I think it is really recommended for these like very few and select use cases where it actually makes a lot of sense, because it is fully automatable and it is kind of, even though it's non-deterministic and there's a lot of non-deterministic aspects to it, you kind of know that it doesn't need to run for like days to succeed. For example, like the task is still pretty well defined in a way. I think those are the use cases where I would probably recommend this the most. And yeah, that's also another consideration for this as well, is like the more complex your networks become and your tasks become, the more difficult it is to prompt. So if you imagine that an agent is hard to create instructions for and it's hard to prompt from time to time, this is now exponentially more difficult because you're having to combine all these different primitive descriptions, and you have to write the instructions for the agent network, and then your task description is going to be large and complicated.
Yeah.
Because it has to be like transcribable to these different components that your agent network has.
Yep.
So whatever task you're using this for, it has to be either very clear what all those different components are, so it's more doable to actually like write all this information down in a set of instructions that actually can work, or it should be like still relatively a well-defined set of problems that your agent network can then just solve without you having to necessarily write that workflow, because it can be painful at times. So
yeah. Also, there's also this other possibility that makes this even wilder, which is this. 1 second. Where you could have a network in your network.
yeah.
And so talk about inception, right? But that's just yet another primitive. Like any Mastra primitive that can be accessed will be accessed. So like you could create some really crazy shit if you want. Not that it's recommended, but also like this, Tony, we were talking about this once about these background tasks that people can do. So for example, like if you get an alert, kind of coming back to the T3 chat thing in a bit, or for a bit. Also, Tony and I have been in so many firefights, both together and individually, that a lot of this stuff is like PTSD when you think about all these things. But a lot of those times that we were in those firefights, we spent the first time in the research and discovery phase checking all of these systems and alerts and graphs and kind of structured and unstructured data to determine like our first hypothesis of what could go wrong, right?
Mm-hmm.
Agent network is the greatest, a really great tool to do something like that if you can figure out the pieces, because when given a trace and the right workflows to go and like check things, like, oh, go check the uptime of this, go look at the database CPU usage, go look at when the last release was, go do a git bisect on some shit. Like you could code all those things into tools and into workflows. And then you could essentially, when you get an alert, let's say, and if the network runs in an appropriate time, you could come to a problem with a whole deep research of what happened, you know? Which is why I think when you sit in perplexity and you're writing some deep research shit while you go watch a YouTube video, that's a fucking dumb use case. You know what I mean? In my
Yeah.
opinion. Like no one's gonna sit around and wait for shit. Like this all has to happen in the background and it has to be pushed to you, right? A network is like a little squad team goes and does some reconnaissance and comes back, right? So that's just my opinion on shit right there.
Yeah, I think that's ultimately the use case that I would have primarily in mind as well. Is something that just kind of takes some kind of like a tedious problem analysis to action kind of a workflow just off my table. Whether it's figuring out something in alerts or logs or something, or maybe finding TypeScript errors in the code base and trying to figure out what changed, or it's all kinds of like these problems of something's wrong. Why is it wrong? Can you just go and analyze what's happening and then let me know what I need to do, or if there's something that you can do, just do it.
Yep. We also had this YC batchmate called Harper, and they were killing it during YC. They're killing it now, and they do insurance for companies and people and stuff. And like most insurance providers, like you fill out a form, right? But then based on that information, the case worker or the underwriter has to go and pull all this data from different places to assess like whether what your insurance rate will be, how much is your copay, all that bullshit, right? That's another agent network type of task, right? If you have all the tools, you could build products that are essentially form fillers that go and do things, even like real estate assessment. I've filled out so many forms about, like put in your square footage and all this bullshit and we'll get you the best deal. Like today, those are all probably just programs everyone wrote, but this could be more dynamic in a way. So there's more use cases there that are actually real than when people talk about this stuff. I don't feel like they have real good like use cases, right? Like if you look at the LangChain supervisor bullshit, it's like tell me a joke and tell me a math or do some math. Like that's not a real use case because you could do math yourself on a calculator. And you can always come to me for the jokes. Like, why do you need to use a supervisor agent for that? But anyway, Tony, can we show some code, like just kind of like maybe the internals a little bit, and then we'll bring the other guys on.
Yeah, let me see.
Also, we have 329 people in here, which is absolutely wild. So welcome. I'll do a quick recap because I'm supposed to. Welcome to AI Agents Hour. I'm Abhi. This is Tony. We're both from Mastra. If you didn't already know, probably you do. And then today we talked on AI News. We talked. Damn, I hate doing this shit, Tony. It's so annoying. We should build something that just automatically recaps it for us. Okay, so what we talked about, AI News, we talked about T3 Chat's outage and how you should be more empathetic to people who are operating software applications, and how T3 Chat is really cool, so you should try it out and all that. And then we also talked about some this time that Google fucked us over with quotas. I'm going to keep saying that in the recap because Google did fuck us over in those quotas. Then we talked about Osmosis's SLM, small language model that helps you take unstructured text and gets really good results with structured output. Then we talked about our tool compatibility research. And then lastly, we talked about Meta trying to replace 90% of the trust and safety with AI, which we thought was very self-serving and probably just for money. And now we talked about agent networks as an architecture diagram, and then we're going to show some code. And if you could zoom in like 3 times or whatever.
Yeah, I'm just trying to get set up here real quick.
Cool.
So I just merged main into this branch, and I think I broke something. So, but I think it's good enough to view at least right now. So, This good? In terms of the font size, we're good?
Yep, I think so. Maybe a little bit, one more, maybe.
Um,
There you go. I'll just
try.
do full screen so people can see the whole thing. Yep, that looks good.
And then I'll try and get rid of that too. Okay, so as far as the kind of the basis of the agent network itself, you have the agent network class instance, which has, well, the ID and the name, but also the instructions of the network itself. And this is what really determines what kind of tasks you can pass to your agent network. Maybe if there's any key points that you might want to encode in terms of like any completeness conditions or anything. If you're running like this kind of like looping complex task execution case, then this would be a good place to write up some of that as well. You have the model, which is specifically used for the routing agent. And then you have your different Mastra primitives, like your agents and workflows, and you can have tools here as well, like so. And then you have the memory, which is again this like scratchpad memory instance used by the agent network itself. Whether it is for this conversational history in the first case where we just execute one primitive at a time, or the scratchpad memory for this complex execution case that lives throughout that one execution, then it will be this memory here. Now, there's different primitives here. In this example, I have just a couple different agents. There's like an article writing agent and a research agent. They don't have memory because they are mostly just executing pretty small tasks based on whatever you give them in their prompt. And I have a workflow that is kind of doing some more deep research on a specific city. So it's like a very specific research tool that uses these two agents to kind of put together a more thorough report on an individual city. Now, as far as this agent network goes, if you were to ask it to do research, let's say on the biggest cities in France, let's say 3 of them, and then to find those cities, what it would do, interestingly, is it would first try to use this agent 1 here, which is like a general research tool, to just get only the names, like the names of the top 3 cities in terms of size. It would then, one by one, use this workflow here to do research in depth on all those 3 cities. Once it has that, it would use the second agent to generate an article with that content. So it kind of knows that, okay, like for these specific research tasks, I have those tools. So first of all, the only thing that it needs from agent 1 is just the names. It doesn't need anything else. And then it uses this more specific and more interesting tool to research all of those things individually. If I were to ask you about something else though, like trains or cars or whatever, it would just go directly to agent 1 and then on to agent 2. So this is kind of how the execution flows through. This is the programmatic way of doing these more complex, like what we call looping use cases. As far as like the single call use case, programmatically would go, it's like the same agent setup, same network. You could call either generate. If you ask it about a specific city, it's going to call that workflow. If you ask it just about the biggest cities, then since it's not a specific city, it calls agent 1 instead of the workflow, which again is that research agent. You can also stream these responses. So here is a case of streaming. Basically streams exactly the same way as a workflow because the underlying implementation is in fact a workflow, with the routing step being the actual call to the routing agent, and then there's another step that either calls an agent, a tool, or a workflow, or maybe another agent network. And then, yeah, that's pretty much the programmatic interface.
Yep.
This will mostly be something that you don't have to use programmatically. It's kind of whether you're using use chat or whatever. Like this is the underlying implementation that streams things into your playground. But yeah, I think that's it before we dive into the real stuff.
That's dope. Thank you for doing that. Let's bring in some other homies in here. So for our pairing session, first we'll bring up the main man, Coolio himself. That's what we call him. Taufik!
Hi, Abhi. Hi, Tony.
What up, dude? And then the Monsieur from Strasbourg, Marvin. What up, dude?
Hey folks, how you doing?
So little does everyone know, these pairing set or these live streams. There's this one time that we were on live stream, and this dude was like, "Yo, this is the most expensive live stream ever," and we were like, "Fuck yeah, it is." But then we also realized to make it not so expensive, we should just do real work, the work that we actually do, just on live stream. And so that's what we're gonna do today, folks. Like we're actually gonna do Mastra work on live stream regarding Agent Network, which is why we did this whole preamble, because we wanted y'all to understand what we're doing, because this is what we're working on together right now. So I'll give y'all the screen and let's make some moves. Who's gonna share?
Um, okay, I'll be sharing my screen. Yes.
So 374 of you here. Thanks for being here. No recap from me right now, but Taffy, make sure to zoom in as much as you can, and then I'll make this full screen. I do want to educate people on pairing, like pairing sessions. I don't know if many people do them in your company. I would highly recommend doing pairing sessions. One, it's really fun. Two, in this age of remote work, like it's like the only human interaction you might have in a way, other than you and your LLM, right? I don't know. But then three, it's like really good to learn from others. So how we do pairing is we have a driver, which is Taufik, like he's the one sharing, and then all of us are like either here for help, support. Like if we need to do, like we're agents, right? If he needs us to do deep research on the side, we'll go do it to help him out. That's the goal of our roles here. And then also sometimes I like right now probably I can't do jack shit. So there's always some dude just watching, and that might be me. So okay, let's get into it.
Okay, yeah. I've zoomed in a little. Is
Do
this
like one
enough,
more.
or should I zoom in more? Okay. This
Cool. I think
should
that's
be
better, but then you just gotta like your terminal probably has to become smaller or something.
yeah.
Perfect. Yeah.
Okay.
Looking good, dude.
Okay. So far we're able to like get messages from network stream. I'm sure Tony has talked about the V2 network and all already, the next network rather. And now we are trying to create an interface for you to be able to like use your VNext network, chat with it or whatever. Right. First on the network stable, you see your VNext network with the tag VNext. Same thing we did with workflows like a month ago. And now working on this, we've not done much, but so far, let's say we try and chat with you and say, tell me about BMW cars. Right now, we've not really formatted the response, but the response looks something like this. But this is what we are getting from the stream. So like we can see the different chunks of data that is coming in. And the plan now is to build on different types, try and create a nice UI for it, right? First, we can set this where it starts the step and step result. And I see now this, say here it calls the agent, tells the agent to research about this. And when it is done, okay, during that process, there's a tool stream with this prompt, research about BMW cars, including their history, models, and shit. Then another tool call.
Yeah, there's a bunch of things happening here. Like, have you seen the scroll indicator?
Yeah, I see. It's like so much things.
Yeah. So I was trying to think about what could be a UI on the side, like to show all this information, because we have a lot.
Mm-hmm.
So I don't know, Taufik, but if we try to show some cards, some details about every single of these instructions, we will end up in having a very huge conversation, like something way too big.
Yeah.
That's true.
So my first intuition was like, hey, can we just at the beginning, because some people might be interested about what's going on, but some just want to have access to the result, right? So some people just want to type something when they know it's working and they just want to have a feedback. and other people want to debug the thing, so they want to have access to a bit more information and to see how the information is flowing through the agent and through the tool calls and etc. So I was wondering if we shouldn't start pretty small with the first event, which is start, I think. And when we have a start event, we can just show a collapsible button, something that will open, show a disclosure or something like this, show a big card, or just show nothing, so that it does not flood the conversation with a lot of data. And then we can think about how we show all the other information in an interactive way so that people can have in between quotes real-time data. I don't know what you think about that. If we can start small, would be great, I think.
Yeah, let's do it. I think that's great.
Yeah, I think it's worth noting that looking at these events here, like the vast majority of these events are what are called tool call delta events, and those are basically just the LLM streaming tokens as it's outputting things. So if we were to remove those, it would be probably a smaller set, but then that will be like the individual agent network step execution events.
And also, like, we have these rows that have like matching IDs, right? So like the start and stop, that have, or start and finish. So those can be collapsed as well, or maybe have some. How about we, here's an idea. What if we start by, instead of having three, like for example, there's 3 cards for the start and stop, right? Let's have 1 card that transitions from start to stop for each type. You know what I mean?
Yeah.
Okay.
I'm going, yeah.
Yes.
Or do you want to go even smaller than that, Marvin?
I was just thinking about, something even smaller. I'm sending you a screenshot, Taufik, so that you can, it's an Excalibur file, screenshot, something like this. I can shoot you the Excalibur thing. But you are the driver, you are making decisions, so we can do whatever we want. Exactly, we are free for the user experience of this one for now. We can be creative. And so this is what I was having in mind, like just starting with the think and process thing, and then we can expand with a graph like we have in workflows, for example, where we can see something very interactive depending on the information that we have. But just start with this collapsible thing that you can just press and it expands all the logs, all the information inside, or you can just collapse it and you don't see anything at all. But we can start the way we want.
Let's do that. That's tight. Can we do that? Let's do it.
Yeah, I think I can do this. So if I come down to...
Lucky I'm not the driver today, to be honest.
The stream has a bunch of Excalibur on it, dude. We're just drawing today.
But if you have it, this is just something that I was thinking on the side. If you have better idea, let's go.
No, this is great. Let's do it.
We'll have to make a lot of changes here. We have the system message. Probably have to create a new one. But first,
to be honest, I don't know that much about Assistant UI and all these kind of things. Do we have a way to convert one specific message based on the type or something to show a UI?
Yeah, that's what I'm thinking about. What we'll probably have to do is use these 2 fallback rules. So right here in the runtime provider,
I'm going to check if I see something here on Assistant UI docs.
Like different tools. Same way we do in tool call part.
Yeah. If we are able to go in a place where we can basically a factory place, like we have an identifier and we can return anything from there, that would be super nice. But I don't know if it's possible with Assistant UI. I assume yes, but I don't know how.
We're about to figure it out.
Yeah. Just like music.
DJ Mastra, baby.
We have to finish this one too. At some point.
2 fallback custom. Then we have this 2 fallback. Yeah. be able to do this. Show the result. The type is one we show one is this.
So yeah, what type of information do we get inside this component from?
For the tool fallback.
Yeah.
You get tool call ID, you get the
Okay.
results, all that type of stuff. That'll take care of all the tool calls for sure on the page.
Yeah. So what I'm thinking is, because that's would most likely have to use something like this, or we create our own the version for network chart for VNet network. This different.
I've sent a message to Claude, which is one of my best friends these days. Super nice. And he's actually telling me that we can have a custom message somehow that renders the user message or the assistant message from assistant UI. And we can conditionally render those.
Your hit. We have this markdown text.
Yeah.
This
we have
is
some.
This is the custom component that we are using right now for assistant message.
Okay. Going to check something at the thread level.
Come down to markdown text. Just shows it.
Abhi, what are we in the chat right now? Like, what are we like when we're rendering those JSON objects? Where's that in the code base? Can we go there real quick?
So this is it. Right now we just stringify the record we get from the stream.
Nice, nice.
Most likely here, then we'll have to start formatting the records. Like
okay. And can you pass components in there or this is the data? Okay.
Yeah, this is the data.
Yeah, but I think if you go in the thread.tsx file, which is in Playground UI, Assistant UI, the thread file, I think there is a way to do it. And if you go
here,
you have somewhere where we register user message, I think. Yeah, right here. If you go in the components object, you can add a message one, which is an additional one. You can add a new line, which is message. And you can basically return some JSX from here.
Just put a hello world up in there.
Yeah, just to see if it works. Because compared to user message, assistant message, I don't know how it will behave. I mean, just from the top of my head, I'm just curious. So just to see, So we have an issue at build time. What is the issue? Fetch command. Service runtime record. Okay.
Yeah, I'm going to remove that.
Yeah, before building, can we try something else just before? Can you go back to the thread thing?
Yeah.
I just want to see more information since we are running a build. So can you add the props in the message component that we see here? Yeah, and just log them so that we know what we got instead of having to run a second build. Super nice. Yeah, cool. Thanks, man.
Tabs are the best.
Yeah.
$411 people in here. No pressure, Taufik. No pressure. Just kidding. They're not even there.
Yeah, it's like being at a concert, but you're not in the crowd. You're on stage, man.
We're just building our depths.
Yep. All right. I'm excited by the type of UI that we can provide with all this information that we have.
Yeah.
And I'm also wondering, Tony, do you know if it's easy to add a started at and ended at information?
I believe we already have that in the stream. So
Okay, cool.
there's different type of events, and I do think that we have that already.
Okay, cool. Thanks.
But yeah, if not, then it should be doable. We have access to like the emitter that's basically puts together the whole workflow stream. So if we need to do something specific, we can always send a custom event. But let's first check and see what we have.
Yeah, sure. Super nice. Thanks.
Actually, maybe like if you mean the actual timestamps, I'm not sure that we have those, but we have those in the actual snapshot. So if we have the run ID, I guess we can ask for those. But let's check what the best way to do that is.
Yep, sure. I don't think we have anything regarding the message, right? It's not the right path, I think.
Oh, there's a props. Oh no, never mind.
Nothing.
Not yet. We don't have it here. So that's not the right way to do this.
But let's replace the assistant message, right?
Yeah,
Let's replace that with the hello world.
Yeah.
Also, chat, if you guys never mind.
If you know.
If you know assistant UI, but you know, that's a very new library, so.
I like those APIs, but at the same time, it's sometimes a bit hidden what you want to achieve, which seems pretty simple. But since it's a bit outside of what they are supposed to do at the beginning, it's sometimes a bit harder to just, at the very beginning, wow, speed is like 10 times faster.
Yeah, if you just want the basic or out of the box.
But I'm pretty sure they have a way. But yeah, we just need to figure out. Yeah.
Maybe we should invest in like a storybook too for this, so we can just mock data.
We can also. We could also.
I'm gonna write that down for later.
Yeah, I think this approach is a better one.
Yeah. There's a lot of cool things that come out of pairing session chat too. It's like you'll find out things that you need to do for the future. You would only do it by feeling the pain, you know? But we out here. Nice.
Okay, let's see the logs.
Hello world.
But we don't have any data.
That's okay though. Oh wait.
But that's fine. That's fine because there is a hook.
Yeah, the record hook. Or...
There is a use message or a use runtime message in Assistant UI that we can use. Do we have access to use message somewhere? I know this one I was trying to use it. Use message. We have it in the assistant message, for example. Which is, if you go on if you jump on this one. We have access to this use message that should have more information.
Nice, let's copy that.
And then get the data from that one. Use it. Let me just create a component and render. Then it's easier to.
So let's see. Maybe we'll have everything we need, and we have our factory, or
Let's try about the rest.
yeah, you can directly pass it. I mean, without having to wrap it, you can just, like we did with user message and edit composer, you can just put it as the value of.
Yeah, I think this works too.
Should work too, yeah.
Not force. Take time. That's beautiful, not force. How to do it force? I'm sure this part is correct.
All right, let's build it again.
The pain of building.
I mean, remember the pain of Webpack at scale? It was just crazy.
Yeah.
Remember Gatsby time?
Oh my God. Gatsby dev. Don't even remind me. Holy shit, that was slow.
Man. With preview, it was pretty nice at the end. But at the beginning, when you, yeah, it was pretty slow.
Ah, shit, I clicked the terminal mistakenly. No, things are not fine. Good, I'm here.
Do you have an issue?
Yeah, it's a build failure.
It's telling me there shouldn't be errors.
50 errors.
There's no error anywhere here. It's on temporary. Okay.
What command did you run?
Build. I think I
Okay.
cleared a different terminal, the previous terminal mistakenly. That should have cancelled it though. Just the create thread to use. I'm going to rename you.
Oh, you're exporting the same thing, and we export that in a root file, right? So it has the same name or something.
It's a different name though.
The file is different, but the export's the same name, right? But I guess it doesn't matter if it's not being exported.
Sure, not too much.
No, you're right.
And then next. Find the first editor. Domain. Instead of thread. Separate you fully. Don't threaten the other guy. My God. Something wrong
How did
somewhere.
this break? Or how did this change?
There are no errors in any of these files.
But it's a TSC thing, like about any's, right? But like, what would make it have changed all of a sudden?
Yeah. What the hell here? Okay. Need to rebuild core.
Oh, did you pull or something?
The last core build failed. It got terminated suddenly. So that's why things started to go wrong. Yeah. Should build fine. Click on the eye. Data. Content. Okay, yeah. Data the content contains which information that we need.
Nice.
Let me just try and get the final data and show first.
Yeah, I think we can deal with the LLM streaming last. So the delta events. I think those will probably be the last event for us to look at.
Yeah. We can start like step start or something.
Yeah.
So this if I just return this first. I want to find a way to recognize the final data, like exactly how to know what it is. So I can pass that as the message and then after that start handling the different types.
Yeah, I think there's a very specific event. Like there's a start event which starts the whole workflow execution. I think there's a similar one for the very last one.
Yeah, I think if I check this, the last record. Let's finish.
I may have seen it type finish. That's possibly it. 'Cause that's the step one, but then the one below that is just the overall finish event, which is like the whole workflow has finished executing.
Yeah, though this finish does not have anything other than one ID. Metadata is empty. This step result. Yeah, this everything is. Type of step results. There's so many step results. Give us a step result from agent step. What?
But these record logs are not the ones that are coming from our component, right? They're coming from
No.
somewhere else. Those are
These
coming when we
from-
set.
These are coming
It's
straight
the
from
actual,
network stream.
Okay.
yeah, that's the actual like workflow streaming. So this is like what we want to observe, and then we just want to display it
Yeah.
somehow. So I think as far as the steps go, like we know what the step IDs are, so we could just only look at the routing step and the actual execution step for this particular view, and then just record the outputs of those so we know what primitive was run and why, which we can then display separately, and then we know the final result as well from the other one. So perhaps that's the way to go. Is first of all filter by type step result, but then also filter by just the specific step IDs, right?
I want to see it here. The full chunk. Hold on.
So each one of these is an assistant message. That's just the text is JSON, right? Like just a
Yeah, the text is different.
cool. Can we go to that wrapped assistant message then?
Yep. I was talking in the void. I was muted for like 3 minutes. Oh man,
Oh, dude, that happens on pairing sessions too.
that's
Yes,
annoying.
let's go to that where we're displaying this assistant thing.
Yeah.
Then let's JSON parse this bitch. Oh, this thing. Sorry.
Like the new one that we have created. The one with use message. Well, I mean, we can try it here if you want.
Yeah, which
Yeah,
one?
we can do it
What
here.
are we actually using right now?
Just going to duplicate this.
Yeah, this one.
Should come from
Yeah, so but we don't want to use markdown text, do we? Or
No, I think we don't need what's below. I mean, yeah, we could in a sense that if we have other assistant messages, we still want them to be shown like this. So, for example, if we since it will just be the new assistant message, we will still need to have support for what was previously existing. Taufik, do you think we need this JSON parse thing? Because if I remember correctly, we stringified the object at some point to show it in the UI, and I'm just wondering if this one is needed.
Yeah, if we want to like see the type for each object, pass it.
Okay.
because we are using type text, right? So we're inserting each message as type text assistant with a JSON stringified payload, which is, I guess, fine. I think, isn't there type data? But I don't know. We'll come back to that. Let's just roll with this.
Yep.
But that way, so then the markdown text component that we're passing in the components object is just taking that content value as text and rendering it.
Okay.
That's why we're seeing our JSON stringified shit, right?
Okay.
So I was thinking, just as a hack, right? Not for real. We could not use markdown text, and we could do something in there because we are using these message components. This is why, I think this assistant UI thing has put us in a little bind on this case because we're using this message primitive dot content. So it's just based on the type, text, and content, it'll just render that component, you know?
Yep.
Oh, but this is a singular message, right? Like this
Yep.
wrapped assistant message represents a single message there. Right?
Yeah.
Exactly.
Yeah.
So we don't have to use this shit, like the message primitive at all, if we didn't want to.
Yeah,
I mean,
exactly.
we'll still need those. We'll still need those because we are overwriting the overall assistant message. So it corresponds to any message that is sent by the assistant.
Yeah.
And so we are adding capabilities on top of that. So it means that we shouldn't remove what is existing now.
Yeah.
But what we can do is put a if here, like if type is start, show a collapsible, else just show the markdown stuff or whatever.
Yeah. Let's log that parse content real quick. When you have to do builds, so this is just a general tip for the audience, because we're in this like right now we're in a situation where we have to build this stuff every time. So usually when you have fast iteration loop, you can do a log, hit save, and you're off to the races. But now I would say make as many changes as you can at once.
Yeah.
And then hit build.
Yeah. I don't know if we have incremental build on TypeScript in the project, but that might be something to look at if we don't. But I'm pretty sure Word has already tackled this.
Let's write that down as well. Yeah, we should improve that.
Because we can use a watch step or something. I mean, build watch or whatever.
What do we present here?
I mean, just to be honest, I would just put if parse content.type equals start, return a button or something, and then we can.
I was trying to.
Because I'm suspecting that we will have an object tree somehow that we will augment on every iteration, that we will fill like a store or something like this, or a state that will be filled on every iteration. And this is what will create the chart. So this is how I feel about it. This is how I see it going. Because we have access to, I don't know, that's just a feeling, but.
No, I think so too. We just need a faster way to prove shit out.
Yeah, let's try simple stuff first, and then we can iterate on complex stuff. Tony is waiting for the complex stuff to happen.
Output.
Let's omit a tool called Delta. Let's just do step finish or
step result.
Yeah, step result.
I think I'll say something for this. So step result, output, result. I have two called delta, two called delta, so much of it.
If it's tool called delta, let's return null.
Is there a use case where we would like them to be showed up? Showed up? Not showed up, yeah.
I'm not sure. They should update the component in place though, right? That has the same ID. So
I mean, I think whenever like you're in this one-off use case where we pick an agent to run, the tool called Delta is basically the streamed output of that agent. So I think we should just show it as it's coming up.
Yeah.
So I think that's like at least a very valid use case where it doesn't really make sense just to wait for the agent to generate the whole output because we have it streaming back, right? So
Yeah. Yeah.
Type. So I could say something like
Yeah, for this thing, we will build UI components in not a very regular way. That will be fun.
Yeah, it's gonna be super interesting.
Yeah.
Unfortunately, we have only 1 more minute of the live stream,
Yeah.
but it's okay. We'll be ready. This is a good.
say this is almost done.
Yeah. Can probably just show what's going on.
Almost done. Okay.
Let's see what we get. This is for all the marbles. 30 seconds left.
Wow, wow, wow.
Broke.
No. Oh man, that's hilarious, dude.
Undefined text. Okay, let me confirm something. Data.
Yeah, we'll figure this out.
Yeah. Okay, let's leave it at that. Sometimes you don't get a victory like we did last time with that music player, but timing is timing. So let me stop your share, Taufik. So let me stop that. Now we're all here. Or there, we're all back. Okay, so there's 525 people in here right now, which is dope. And this is the end of the stream. I'm going to do a quick recap, and then we're all going to say sayonara. So today first of all, this is AI Agents Hour. If you just showed up and you didn't read shit, now you know. Today, what we did, we went through AI news. We talked about T3 Chat's outage, how you should have empathy towards people who operate software companies and products. We talked about Osmosis's SLM, which takes unstructured text and turns it into structured output way cheaply. Then we talked about Mastra's tool compatibility research that we did. And then finally, we talked about Facebook's or Meta's commitment to adding AI to replace humans with AI for their privacy and content moderation policies, etc., which we then made a joke that it's probably not it's just to save money or make money. Then we went through agent networks. Tony gave us a whole architecture overview of it. We drew some Excala draws that I think people liked. And then finally, we did a pairing sesh because we're trying to take that agent network and visualize it in our playground. And so, yeah, thanks everyone for joining us today. We'll see you tomorrow, same time-ish, and maybe different people though. But yeah, so see ya. Thanks for being here.